I'm going to show you how this calculator works. It's a scientific calculator with a difference. It can calculate with units as well as with numbers. You can see that the number of buttons is somewhat larger. On the left, beneath the mathematical functions, you have a set of constants which starts with pi, then the mass of a proton, and so on, various constants familiar to scientists. And over on the right, underneath the normal arithmetical operators that you're familiar with, are various units from meters, hertz, farads, and so on. And the idea of this calculator is that it uses dimensional analysis to give your results with their units. And a very simple example is, say, to add two lengths, say 6 meters plus 3 meters, and it gives the answer as 9 meters. Okay, that's a very simple result, but it's a significant one, because what this calculator will do is it will prevent you making errors. Like if I try to add kilograms to meters, it'll say the units must match for added values. Okay, so we can clear that. It's within that there's a lot of checking going on, obviously, and this makes your calculations that much more robust. Here's a simple calculation of the mass of a carbon atom, which will be 6 times the mass of a proton plus the mass of an electron plus the mass of a neutron. Whoops, I've got that wrong. I need to go back, put the plus sign in. Mass of a neutron, close bracket. And you can see that the result comes out with the units kilograms. You can get a bit more complicated than that. If you want to calculate the force of gravity at the Earth's surface on a 10 kilogram mass, we can start with the gravitational constant, which is capital G, times the mass of the Earth, and there's a menu entry here for more constants, so we can go to that and scroll through various constants that are defined here, times, say, 10 kilograms. Now this needs to be divided by the radius of the Earth squared, and again we can get the radius of the Earth from here, Earth mean radius. Raise that to the power 2, and you can see that that answer comes out in newtons. We can not put the 10 kilograms in explicitly if we want to. We can use a memory location for that, and this is useful if we wanted to plot a graph, say, using an equation. So if we delete the 10 kilograms and then use a memory name of M1 into M1, we can put our number, and with the unit if it's required by the equation, in this case it is, and then when we calculate, I put 10 kilograms in, I'll put a different value in, 20 kilograms say, and then when we do equals, we get the answer 196.54 and so on, newtons. We can use much more complicated expressions, and we can save and load them. So in this case, we'll clear that and we'll load one that I've put in before, is a resistivity calculation. This is a bit more complicated. We've got 1.44 volts, a wire diameter 1.2 millimeters and a length of 125 millimeters and a current of 7.4 amps. Now when we calculate with this, the answer comes out in meter ohms. And notice that the ohms were not in this original equation, as newtons weren't in the gravitational force one either. It's a derived unit, and UCalc knows about derived units, and it'll try to use them wherever it can to make the answer as short as possible. So I hope that gives you some idea of the power of this calculator. It really is a better way to do calculations, and if you look in enlightened physics books, they'll always show the calculations with all the units in place throughout the calculation, and it gives you a feeling, a reassurance that you've done actually the right equation to get it coming out with the right units. Okay, thank you very much.